Good morning. The last class we see about the basic of function of how the FEA can be work and what are the difference between FEA and the FEM. What are the characteristics we have to deal with detailing and what is the meaning of FEA we have to study. So basically the FEA is a finite element analysis or finite element method. There is a numerical techniques for finding the approximation solution to boundary value of the problem for the partial differential equations. So, and also how they working, what are the different types of FEA, we have to deal with the last classes. And today class, we're discussing about, and also we have to deal with some of the advantage and disadvantage and the software package of FEA. What are the software package of FEA we have to study. And we today class, we discussing about what are the general steps of FEA. So first of all, there are, whenever you can solve the problem, okay, by using of FEA, so we have to resolve the 10 basic steps we have to follow to do the problem. Okay. The first step we have to using for step one, and the step one is meaning is called as a discretization of structure. The step two is called as a numbering and nodes of element. And third step we have to deal with the selections of displacement function. And the fourth one define the material. So these are the basic steps. Okay. So first of all, we have to discretization of the structure. Either if you have the how many element I have to segregate it, okay, or else if you have categorized the material. For example, during the analysis, okay, there are three different types of methods we have to do. So just here I have to say some few examples. One is a steady state condition, another one is dynamic flow and frequency and thermal. These are the so many process can be during. Okay, so that's why we have to describe the structure. And the second one, what is they call it as numbering nodes and elements. Okay, so first of all, so if I consider, I have to consider one rectangular bar. Okay, the rectangular bar I have to cut into two bar. Okay, so the element one we have to define as a one, and element two we have to define as second bar. Okay, so each bar having a two numbers, that is called as my nodes. Okay, so the minimum of value or maximum of value of the each bar they having a two. Okay, so the similar the second element also it can be number as a 2 and 3. Okay, so these are the categories we have to using for the numbering and node, and the third one is selection of displacement function. For example, I consider a rectangular bar. If I'm rectangular bar, I have to fix it with one end, that is behave as a cantilever beam. Okay, so the where is my point is fixed. For example, I consider the node number one is fixed. So this here there is no displacement occur on it. Okay, but what about two and three? We have to resolve by using of API analysis. So these are the basic conditions. Okay. So then only we have to find out the unknown displacement very easily after applying the boundary condition. So first of all, we have to substituting the general matrix. For us, the general matrix is F is equal to K into U. That is my general matrix. Once you have to substitute in the general matrix based upon your material behavior. So that is the next step for you. Okay. So they have to find out the unknown displacement for the each respective nodes, and also that node can be represented as a bar. Okay, and also you have to define the material behavior. Okay, so what is the material behavior? It's like a composite material or the same material we have to study with. Okay, and also if you're having a composite material, the each composite material having a unique property. For example, the Young's Poisson ratio, these are the both are different it's a different but are same for the all the elements. Okay, and also derivations of stiffness matrix. This is the foremost thing to do the for the to solving the FEA problem. Okay, so whenever any problem you have to resolve, you have to find out the stiffness matrix for the particular element. So I told you know if I consider rectangular bar, I cut it into two equal parts. So the two bar elements are there. So that element having a two stiffness matrix are having. Okay, so based upon the stiffness matrix, you have to assemble it and substituting the general matrix, you getting the unknown displacements. Okay, and also the derivations of global stiffness matrix. Once you have to find out the each bar element. For example, the element one having a some stiffness value, element two value having a some stiffness value. Okay, so both you have to consider. Okay, and joined with each other. Okay, so you have to derive the global stiffness matrix. So this is my sixth step of the stiffness matrix. So okay, and also I have to apply the boundary conditions. So boundary conditions based upon the conditions we have to given a problem. For example, some numerical problem is a deal with the without considering self weight or with the considering self weight. Okay, so without considering self weight means the most of the problem is not mention the density value, but with the self weight means okay. So you have to most of the problem is give the density value after the you have to consider to solve the problems. Okay, and the next one is applying boundary conditions, and the third one is solution for unknown displacement. Once you have to apply the boundary condition, you got derive the unknown displacement. So before getting the unknown displacement or before getting the apply the boundary condition, you have to find out the consider for is a self-weight problem or non self-weight problem or neglecting the self-weight problem. That is the foremost thing to doing the FEA that is experiment or whatever you have to doing mathematical calculation also. Then you have to find out. For example, I said no. So it's a cantilever beam means is a one end is fixed. So that I have to consider the node one is fixed. So what about the displacement? Here no displacement. So whenever which node point having a displacement is zero, you have to eliminate. For example, which one you have to eliminate means you have to eliminate the corresponding row one's column. So I consider u1 is 0 means okay. So you have to eliminate the row and column for the one. So the first row and first column. Similarly, you have to doing for the similar case. For example, I have to fix in the third one, no? So you have to eliminate the third row and third column of the stiffness matrix, okay? And the corresponding you have to cut into the fourth matrix, okay? Once you have to substituting all the data in a general matrix, then only you have to substituting the boundary condition. So it is a easy for that, okay? And is the last one is computation of the strain and stresses is based upon the problem it can be changed, okay? So for example, if you are doing the one-dimensional problem, okay, without self weight or with the self weight, whatever, the stiffness matrix is general formula is E du by dx. Okay, that means d is defined as a change in displacement, that is change in strain. Okay, that is you have to find. Okay, the last one you have to interrupt the result. So what we have to find out, either you have to find out the stiffness matrix or stress or strain, whatever you can do. Okay, the same methodology we have to apply for the ANSYS part also. So once we have to complete all the basics, we have to start for the ANSYS part also. Thank you.